Derivatives number 7 is about how to find derivatives of trig functions, and it is all 6 trig functions. We have sine, cosine, tangent, cotangent, secant, and cosecant. This video is just going to tell you exactly what they are and show you how to use them. There is a separate video that explains where these come from, and previously we had already done through graphing what the derivative of sine x and cosine x were. And the other video is going to explain where the other 4 come from. If you're interested in that, that's an optional video. If not, then you just really need to know how to apply them, and that's what this video is about. Like I said, you know the derivative of the first 2, the sine and the cosine, which are the biggies. They show up a lot. The other ones aren't as popular, but they do show up on occasion. So the derivative of tangent x is secant squared x. And just a little bit of notation on that one. What secant squared x actually really means is secant x, and that quantity is being squared. This is just a way that we can write it without having to put parentheses around it. And the same with the next one. So the derivative of cotangent x is negative cosecant squared. Derivative of secant x is secant x tangent x. And because multiplication is commutative, these can actually be written in any order. So you can call that tangent x secant x if you want to. And then the next one, derivative of cosecant x is negative cosecant x cotangent x. And the bottom line is you just have to have all 6 of these memorized and know how to use them. A little side note to help you memorize them. Any of these trig functions that begin with co, as in cosine, cotangent, or cosecant, notice that their derivatives are all negative. Let's take a look at a few examples. So this first one says find dy dx, and I'm given my function y is 3 cosine x minus 2x to the 5th. The derivative of a difference here, I just do the derivative of each part separately. So I'm going to do the derivative of 3 cosine x. You may look at that and say, oh, well, I have a product here because that says 3 times cosine x, and you would be correct. So you might think we need to use a product rule. So let me go ahead and do a product rule and show you what happens. So in doing my product rule, I did the first times derivative of the second, that's negative sine x, plus the second function times derivative of the first. And notice because one of my factors was just a constant, when I went to do that derivative of 3, I got a 0. So anytime you have a product and one of your factors is a constant number, when you go to do that derivative, you're going to get a 0. And that's going to make the back half of your product rule 0 out and just disappear. So really, the derivative of 3 cosine x is just negative 3 sine x. So the bottom line is, if you're multiplying and one of your factors is a constant, you can just pull that constant to the outside and just do the derivative of that function that has an x in it. And now I still need to do the derivative of this negative 2x to the 5th, which is just a power rule. And that is my answer. I'm just going to rewrite this to make it look a little bit cleaner. And here's my dy dx is negative 3 sine x minus 10x to the 4th. On example 2, again, I'm asked to find a derivative, and this time my function is x times tangent x. Now, different than what happened on that first example, here when I have x times tangent x, I need to use the full blown out product rule because both of these involve x. So my first factor is x, and my second factor is tangent x. And because neither one of these is a constant, I need to use the product rule in its full form. So my dy dx is going to be first times derivative of the second. So I do my x as is, and derivative of tangent x is secant squared x, plus my second function times derivative of the first. And that's tangent x times derivative of x is times 1. And that doesn't really need to be there. You could just write tangent x. And basically that's my derivative. There's no simplifying that can be done on this one. So I'm just going to present this one as my answer. On the third example, again, I'm asked to find dy dx. And this time my y is a quotient, which means I must use the quotient rule. So I'm going to take my bottom function times derivative of the top. So that was this 1 plus cosine x times, and then derivative of secant x is secant x times tangent x. And then I subtract the top times derivative of the bottom. So it's my function in the numerator as is, times, and derivative of the sum, the derivative of the 1 is 0, so there's just nothing written there. And then times derivative of cosine x, which is my negative sine x. And then I have to do that all over my denominator squared. And this answer is big, long, and ugly. And I would say don't do anything to it if you're doing a question like this on free response. But if you're on multiple choice and you don't see this as one of your options, what you would look to do is maybe factor it. In my numerator, I see two terms. The first term is this 1 plus cosine x secant x tangent x. And my second term is secant x times negative sine x. And to factor, I would look for factors they have in common. And they both have this secant x, so I would factor that out. And so this is my factored answer. I just factored out that secant x. And I would say don't try to simplify too much because you might be tempted to cross out that 1 plus cosine x, but algebraically that's not correct because this 1 plus cosine x is not a standalone factor. It is part of this group. So I wouldn't be able to do that, and this is about as simple as I can get. And my last example is a good old equation of a tangent line. They just never seem to go away, and they won't. So equation of a tangent line, what you should think is I need a point and I need a slope, and from that I can write my equation. So for my point, I know my x-coordinate is pi over 2. To find the y-coordinate, I'm just going to plug it into my function. And I know that cosine pi over 2 is 0, and the 0 plus 5 is going to give me a y-coordinate of 5. So my point is going to be pi over 2, 5. And to find the slope, I know I need the derivative first. So I'm going to start by finding y prime. And I just do that derivative term by term. Derivative of cosine x is negative sine x. My plus 5 just drops off. And I need that slope at x equals pi over 2. So now I'm going to plug in my pi over 2. And sine of pi over 2 is 1. So the slope I'm going to use in my equation is a negative 1. So with this as my point and negative 1 as my slope, I write my tangent line equation. And that gives me this, which I'm just going to leave in point slope unless there's some direction that tells me not to. And it just says in equation, so I am done. So just to recap what we have done, you need to know all 6 of these trig derivatives and have them memorized and know how to use them in just finding derivatives, know how to use them in conjunction with other rules like our product rule and our quotient rule, and also know how to use them in writing an equation of a tangent line as well.